Hey everyone, this is our presentation. We decided to create something called the Hydra Spout. My name is Anjali.
I'm Krissy.
My name is Claudia.
And this is a spinoff on the Hydra Flask lid. This is our problem statement and justification.
Our problem statement is Hydro Flask flip-up straw lids are very difficult to clean and leak a lot. A survey was conducted in Reno, Nevada, and 49 applicants replied. 55% of the survey said that cleaning their water bottle lid was ineffective, and 65.3% said it was difficult to clean it. Anyone with a Hydro Flask flip-up straw lid or has a similar lid is affected and has been a problem since the production of lids. The problem justification was the lack of effective and simple cleaning mechanisms or capabilities within the lid results in many people avoiding washing their water bottles and lids, allowing these lids to grow into a wealth of bacteria and mold.
These are the reviews on the product.
These are our previous solutions that we have researched.
The first previous solution was water bottle cleaning tablets.
Straw lid and brush. Made with durable nylon bristles, the straw brush easily cleans inside our bottle straws while the detail cleaner fits into the crevices of caps and lids.
DIY solutions.
Here's our patent information.
This was our solution matrix and the requirements for our lid.
Here are 9 potential solutions that we considered.
This is the design matrix we came up with to weigh our options for the solutions. We ended up deciding on the third solution of the third slide. Here are our specification priorities for the Hydro Flask lid. Here's our prototype.
This is our first prototype, and we needed to make some modifications to it. And this is our nozzle for the straw. And this is our second prototype, and we ended up hollowing this out and making some small changes so that the straw could fit into the spring mechanism.
Here are our testing procedures. Stage 1, ease and accessibility.
Stage 2 of testing was health/anti-decay.
Stage 3, suction.
Here were the results. Stage 1, accessibility. The test subjects came to a consensus and said that it was relatively easy to remove the nozzle, but it was difficult to put it back with ease. They said that they would buy the removable nozzle if it was easier to put back, but they liked that they were now able to clean their lids much easier and more effectively.
Here are the results for Stage 2. We tested only the lid for microbial growth by taking bacteria from our shoes and pencils and rubbed it all over the lid. We then let it sit for a few days and scrubbed away the dirt. To improve our product, we would change the material we use to ensure that bacteria does not stick in crevices of the 3D printing film.
Here's our results for Stage 3. We took the straw and sucked water up to see how and well it would function with water. It worked very well, and the straw was easy to suck through. The person who tested kept the pressure the same for each time.
Here is our analysis. To create viable testing procedures, we had to reprint our prototype a few times to make sure the nozzle fit. To improve the final product, we need to 3D print our model more to scale, have all the pieces fit together, and use a different material. Because we were unable to case our spring in silicone, we were unable to test it. However, that is another way we could improve our design. Our test subjects said that it was difficult to remove because the spring's holes on the lid were too low. So to improve the design, we would bring the holes up higher and recheck our measurements to have everything fit perfectly. Here are the STEM concepts.
For this concept, we will be incorporating a rubber encasing for the spring part of our removable nozzle and using it to create a better seal in the lid to prevent leakage. It is to prevent rusting in the spring and hopefully prevents mold growth to an extent.
Technology. For this concept, we will be using the 3D printer to create the plastic model of the lid. It will be for the prototype and the final result.
Engineering. For this concept, we will be using the engineering design process to thoroughly plan and create our product. We will be designing our product using 3D printers and using Onshape to create the design.
The art for this concept, we will be creating our lid to have this design of the original Hydro Flask flip-up straw lid. We want to make the design aesthetically pleasing. To create an artistic design, we will be using Onshape.
Math. For this concept, we will be needing to measure out the dimensions of the lid and make sure that all the pieces will be able to fit together. This is crucial because it will play a role in preventing leakage and allowing the nozzle to be removed with ease and still be able to allow the straw to function.